Hi friends, welcome to our channel. Let's have a look at problem 1382, balance a binary search tree. In this problem, we are given a binary search tree and we want to make the tree balanced. So here we can return any of them if there are multiple answers. So the definition of a balanced binary search tree is this. The depth of the two subtrees of every node never differs by more than 1, right? So you can look at example 1. So here is a balanced binary search tree. This is also 1, right? So if you look at example 2, it's already balanced, right? So here the number of nodes in the tree is in the range given by the closed interval 1 and 10 to the power 4. And the node value is positive and bounded above by 10 to the power 5. So this one is not very essential, right? So in this video, so we are going to provide two formats of solutions. So two formats of solutions. So here, the first one, I'm going to first get a list and then build the tree. So here, the list is a list of node values. And in the second one, I'm going to get a list of nodes and then build the tree, right? So the overall principle is this. So for binary search tree, so if you do in-order traversal, say in-order traversal, so you are going to get a sorted list, right? So from small to large. So here for this one, if you do in-order traversal, each time you need to first look at the left subtree and then look at the node and then the right subtree. So this gives you 1, 2, 3, 4. This gives you 1, 2, 3, right? So with that said, let's go to the coding part. So let's look at version 1. So the first thing is to get a list of node values here. This should be rather straightforward. Here, let me write a hyperfunction. So get list. So given the root. So this function we are going to write is not confined to binary search tree. For any tree, binary tree, you can do such in-order traversal. However, for binary search tree, the result yielded will be a sorted list. So first, if not root, so we're going to return an empty list. Otherwise, we're going to return get list. So we first traverse the left subtree and then concatenate with the root value. So here, writing this root value is legitimate because we have already checked the null case, right? So this is indeed a non-null root value, tree node. Therefore, we can access the value attribute. And then we go to get list root right. So you can see check this get list the root. You can call this function and print out a list. So for this one, you are going to get 1, 2, 3, 4, right? 1, 2, 3, 4. For the second one, you are going to get 1, 2, 3. With that done, now let me continue. So next, we're going to build the binary search tree. So here we're going to use recursion. So again, I'm going to write a build hyperfunction. So here, given the list, first is if not a list. In other words, it's empty, so we're going to return none. Otherwise, so let's get the length of this list. So if n equals 1, right, just single element, so we're going to return tree node. So you can look at the class here, tree node. So we can set the value. So the value will be a list, and just one element, 0, right? Otherwise, so we can first get the current root. It's going to be tree node, a list. Then we should see this will be the length. Let's see, we retrieve the length of a list. So at the middle, right? And then we are going to set the left subtree and the right subtree. So the left subtree is going to be built, so build BST. So in the previous part, so basically a list from 0 to say length a list over 2. This is the interior division. So the right subtree is going to be this. So because we have already used this one, so we're going to list, say this will be +1 and to the end, right? Then I'm going to return the current root. So here what we can do is just call this function build BST and then use the list given, right? So let's do a quick check. It passes all the cases. But here, let me just simplify a little bit. So here I just get n. So here is n over 2. Here is n over 2. So let's run it. Yeah. So this is the one way, right? So basically, first do in-order traversal. Secondly, using recursion to build the tree. But here what we saved is the value, the node values. So now let me do the second version. I'm going to save the nodes. So here I'm going to call this one version v1. So this will be the most straightforward one. And then the second version will be the same in idea, but I'm going to store the nodes. So first check if not root, so we're going to return, or you can return none. So this is one. So next I'm going to get nodes, and then I'm going to write a function to retrieve all those nodes. So define in-order traversal. So basically from the nodes, given a node, so from that node we're going to do traversal. First if node, if not node, so going to return, right? Otherwise, so we do in-order traversal for node left, and then the nodes is going to append with the current node. So here we are not appending the value, node value, but we append the whole node. Then we do in-order traversal for node right. So then if you call this function, because this node is mutable, so it will automatically modify this one. So you can try to print out this nodes, so it's not going to be empty, right? So node is not defined, so here I think we should have in-order root, right? Yeah, this will be the same. I guess we use more space. So with that done, now let me do a function to get the balanced tree. Tree. So here we are going to pass in the two indices, so corresponding to this one, right? So first, if L is greater than R, so we just return none. So basically we are going to build a tree using the nodes in between the left and the right, so inclusive, both in the inclusive. This one, and then we get the mid, it's going to be L plus R integer with division by 2, right? So the root, just use current root to distinguish with this one, but it's not necessary. The root will be nodes mid, right? Notice that this is already a tree node. So what we are going to do, current root left, so we're going to get the left subtree. Current root right, we're going to get the right subtree. So here we do balance tree. So here we're going to start from L to mid -1 because we have already used mid. So here balance tree. So we're going to start from mid +1 and R, right? So what we want to return is the current root. So this is the full function for build the balanced binary search tree. So now we just need to return the balanced tree. So the left should be 0, right? The right will be the length of the number of nodes -1. So let me do a quick check. Yeah, it passes the 2 cases. Now let's submit. Yeah, this looks faster, but essentially would see the same time complexity. But here, and when we do this set, these 3 lines here, and these 3 lines here. So overall, it's similar, but the difference lies in. So here we build, right? But here we just use the nodes, right? With that said, I guess that's about it for the current video. If you're interested in practicing more leetcode problem, you're welcome to check out our YouTube channel and look at the different playlists. With that said, thank you.